Hi, I'm Kian. In this video, I'm gonna go over some high school introductory physics question, and here we go. So here we have a diagram that shows a series circuit containing a battery and three resistors. So we want to find the currents. So you have to remember that basically voltage is equal to resistance times current. And here we're given a voltage of 12 and the resistance, because we're in series, you can just add all of these up. And so we get 13 times I, and so if we solve for I, we just divide by 13, we get 0.92 as our answer. So our answer should be A. And just let you know, I'm gonna cover multiple choice question in this video. I'm gonna post separate kind of video on the open response for this exam. So we have a investigation, student physically conducting investigation, motion detector, there's a block, there's a pulley, string, position of Y, hanging object, and we said that the block and the hanging object move the same constant acceleration, friction and resistance acting on both, and then student completed 5 trials, as shown here. So the question: which of the following best describe what happens to the energy of the hanging object as it moves closer to the floor? So first of all, we have to notice that in this case, the hanging object is the object here, and you have to consider kind of the change in energy that happens as the object kind of loses, as the object kind of changes from a higher kind of position to a lower position. And so basically, what we can say is that as the object kind of loses its height, the potential energy, or the gravitational potential energy, is transformed to kinetic energy. And the reason is because we know that gravitational potential energy depends on two things: one, the mass, and the other, the height. And so as the height decreases, the gravitational potential energy is kind of transformed into the kinetic energy. And so choice C should be our answer. And let's go to number 13. Which pair of diagram best compares the tension force acting on block at position Y and position 5? Trial 5, sorry. Trial 1, trial 5. So the tension force is basically the force that kind of is given by the string that kind of pushes it forward and opposes, and the force that opposes tension is the friction force. So for trial 1, if you notice, we have a net acceleration of 2 meters per second squared. But for trial 5, we have a net acceleration of 3.8. So there's a drastic change of 1.8 meters per second squared. And so by using our Newton law knowledge, as the acceleration increases, of course, a greater force must have been applied. So the net force must have been greater in trial 5. Therefore, the tension force must have been way kind of greater in trial 5 compared to trial 1. And so our kind of our diagram should show a greater tension force in trial 5. And so our answer is choice B. Yeah, so we can move on. In trial 5, the block traveled from position X to position Y, had a velocity of this, was a kinetic energy. So you have to just know the formula, that kinetic energy is 1/2 times, mass times velocity squared. We don't need the time, it's just given to maybe confuse you. We're given the speed, or the velocity, and the mass. We're set that the block has a mass of 0.4 kilograms. And so if we just plug in, you can say 0.5 times 0.4 times 2.33 squared, we're given a 1.09, which should be answer choice A here. And it's measured in joules because it's energy. Let's move on. So parts A of question 15, which free body diagram best represent the force acting on the object as it accelerated across the table? So this kind of keyword, accelerated across the table, is basically the force that is applied by tension. The tension force kind of caused the object to accelerate across the table. And so we know that the tension force must have been greater than the friction force. And since there was no movement downward and upward, the forces that are upward and downward, which is the normal force and the gravitational force, must have been balanced. So we can now just like use to kind of cross out option D and also option A, because here friction is greater, which doesn't really make sense. Here normal is less than gravity, doesn't make sense in our scenario. And here this shows that forces are all balanced, so there should be any movement, or you're given that it accelerated, so there is some net force. This is also false, so we're given choice C. Let's move on. Part B, as a block accelerated across the table, so as it accelerated, since there's a net force on it, then the speed obviously increased. So we have our answer, choice A. Let's move on. So here we have open response. I'm going to cover these definitely later. These are pretty easy questions, but still I'm going to cover it in future videos. Okay, this question. The velocity of a 75 kilogram skier increases from 8 to 12. What is the change in momentum? Change in momentum is the final momentum, so P final minus initial momentum. And you have to know that momentum is the product of velocity and mass. So it's basically 75 times 12 minus 8, which is 4. So 4 times 75 is just 300 kilogram meter per second. And so we can move on. 18. Diagram shows a negatively charged sphere in a suspended distance d above another negatively charged. So which of the following would increase the distance d? So we have to kind of think a little outside the box. So here we have two negative charges. By our knowledge of similar charges, we know that these obviously want to repel each other. And so, but we also know that by the Coulomb's law, that the more charge we have, the greater the force, whether it is attractive force or in this case, there's a repulsive force. So if you want to kind of increase the distance between them or create kind of a larger repulsive force between them, we have to basically add more negative charges to make it kind of a, it's only one choice, add. So add more negative charges to make this kind of a greater force, and so they repel each other even further. And so, yeah, you have our answer. Let's go move on. 19. Which graph represents the motion of an object that has zero net force? Okay, zero net force is a keyword. Zero net force means that there's no acceleration, that the forces are balanced. Either the net force is obviously zero, and so there's no acceleration. And if you want to kind of go step by step, we can see that the slope, so we're given a velocity versus time graph, and so we know that acceleration is a slope of a velocity time graph. And so if you want to have an acceleration of zero, we must have just a horizontal line that has a slope of zero. And its answer is D. Obviously, this has a kind of a changing acceleration. This has a positive constant acceleration. This has a negative acceleration, but the acceleration of this is zero because the slope is just a horizontal line, is zero. Let's move on. Number 20, this is also open response. I'm going to cover it later in future videos. Similar with 21. Okay, and session 1 is finished. I'm going to cover the next set of multiple choice questions in my next video, and goodbye.